Hello students, in this lecture we see the fourth example in the miscellaneous exercise of the differential equation. In the last lecture we see the third example, that is the formation of the differential equation. Form the differential equation by eliminating the arbitrary constant. Okay. But in the last lecture there is a equation is already given. We only differentiate and remove the arbitrary constant. But in this lecture we see the examples where the equation is not given. There is a conditions for the equations are given. First find the equation from the given conditions and then differentiate to form the differential equation. Okay. Now here it is a example number 4. Form the differential equation. Here form the differential equation of all circles pass through origin and whose center lie on the x-axis. Center lie on the x-axis. That means the y coordinate of the center it is a 0. Here we take x-axis and the y-axis. Here center lie on the x-axis, it is the origin. Center lie on x-axis on the positive side or the negative side. We take here. Here it is the center. Okay, and center lie on x-axis and passing through origin. Circle passing through origin. Therefore, the equation of circle we can write. Here it is a circle. Okay, we consider it is a center h comma 0. Okay, see carefully. And circle passing through the center, that means y-axis is a tangent to the circle. Okay, because here it is a center and this CO is a radius, okay, which is perpendicular to the y-axis. Therefore, y-axis is a tangent to the circle. Therefore, radius it is a h. That means we know the center and radius, and to form the equation of the circle we know the center and radius of that circle. Okay, when we know the center and radius we get the equation of the circle. Okay, now here solution, let C h comma 0 be center of circle passing through origin and center lie on x-axis. Okay. Therefore, equation of circle. Okay. First, to find the equation of circle, first we know the radius of the circle. Here, therefore, it is h is a radius of circle. Okay, and therefore the equation of circle is equation of circle. We know when we know the center and radius. Center it is h comma k and radius it is r. Therefore, the equation of circle it is x minus h whole square plus y minus k whole square is equal to r square. Therefore, it is x minus h square plus y minus k square. K here it is a 0. Okay, and is equal to r square, that is a radius square and radius it is a h. Okay, now first we simplify this. Here it is a x square minus 2hx plus h square plus y square is equal to h square. And now in this equation this h square get cancelled. It is x square plus y square minus 2hx is equal to 0. Now here it is a equation of circle where h is a arbitrary constant. Okay, here h is arbitrary constant. H is a arbitrary constant. Now differentiate with respect to x. Here it is x square plus differentiate with respect to x. The derivative of the x square it is a 2x square, sorry 2x plus derivative of the y square, it is a 2y dy by dx, and minus it is a 2h is equal to 0. Now it is a differentiation. Now here it is a 2x plus 2y dy by dx is equal to 2h. Then 2 to get cancelled, we get x plus y dy by dx is equal to h. Put this value, put in, we write this equation as a 1. Okay, put in 1. Then we get x square plus y square minus 2 into x plus y dy by dx into x is equal to 0. That is x square plus y square minus 2h, h it is x plus y dy by dx into x. Then x square plus y square minus 2x square, 2x, and it is x, 2x square minus 2xy dy by dx is equal to 0. And now last answer here, y square minus x square minus 2xy dy by dx is equal to 0. Okay, here it is our last answer. It is a required differential equation, or we can write throughout multiplying by minus, then we get it is a x square minus y square plus 2xy dy by dx is equal to 0. Okay, it is the last answer, or it is, okay, is required differential equation. Okay, see carefully this. Okay, it is a equation of differential equation of a all circles passing through origin and center lie on the x-axis. See carefully this. Now we see the next example. Here, from the differential equation of all parabolas which have 4b as latus rectum and whose axis is parallel to y-axis. Now we want to find the equation of the differential equation of the all parabolas whose length of latus rectum is given, that is a fixed 4b. That means it is a b is here, b is not arbitrary constant. Okay, it is a fixed length of latus rectum, it is a 4b, and whose axis is a parallel to the y-axis. Axis is a parallel to y-axis. That means our parabola is, it is a standard parabola. When axis as a y-axis, then the equation of parabola it is x square is equal to 4by. Okay, here axis as a y-axis and center, it is a vertex at origin, but here axis is given to the parallel to the y-axis and vertex is not given. That means parabola is anywhere. Okay, here axis is a parallel to the y-axis and here center is any, sorry, it is vertex. vertex is a any point, and any point it is a h comma k, and then the equation of when vertex h comma k and axis is a parallel to the y axis, then the equation of the parabola, it is x minus h whole square is equal to 4b y minus k. Okay, here it is a equation of the parabola whose axis parallel to the y axis and length of latus rectum it is a 4b. Okay, now here let h comma k is vertex and the axis is parallel to y axis of parabola having length of latus rectum is 4b. Okay, see carefully this. It is a parabola. We take here vertex, then parabola like that. H comma k. It is a axis is a parallel to the y axis. Okay, here the equation is x minus h whole square is equal to 4b y minus k. Okay, see carefully. Here h and k are the arbitrary constant. Here 4b it is a given. It is a fixed constant. 4b it is the length of latus rectum of the parabola. But here vertex is not given. Therefore the h comma k, h and k are the arbitrary constants. Here h and k are arbitrary constants. Okay. Therefore we differentiate this equation. We write this, it is equation number 1. Therefore differentiate with respect to x. When we differentiate with respect to x, here the differentiation, the derivative of the x minus h whole square, it is a 2x minus h, and the derivative of the x minus h it is a 1. Then it is a 4b, it is a constant, and derivative of y with respect to x it is a dy by dx, and derivative of k is equal to 0. Therefore this can be written as it is a 2 into x minus h is equal to 4b dy by dx. And now also this 2 to get cancelled. Okay. Here 2 to get cancelled, we get the equation x minus h is equal to 2b dy by dx. See carefully this. Okay, when we differentiate okay, here now again differentiate with respect to x. It is derivative of x, it is 1 minus 0 is equal to 2b constant, and the derivative of y it is a d2i by dx2. Okay, and therefore the last answer here it is a 2b d2i by dx2 minus 1 is equal to 0 is a required differential equation. Okay, see carefully this. Okay. Here the 2 arbitrary constant, so we differentiate 2 times. It is d2i by dx2. First derivative it is this. Okay. Then 2 to get cancelled, we get this relation. Again differentiate, the second arbitrary constant also remove, then 1 is equal to 2b d2i by dx2, and then 2b d2i by dx2 minus 1 is equal to 0 is our required differential equation. Okay. Now we see the next example. Now the third example, form the differential equation of an ellipse whose major axis is twice the minor axis. Now this example is already done in our exercise 6.2 and the example number 4, okay, in our video lecture number 4, okay. Here now, so we take the example number 4, okay. Third example, for the solution of the third example, see our lecture number 4 of this chapter. Now the fourth example, form the differential equation of all the lines which are normal to the line (3x minus 2y plus 7 is equal to 0). Here now we want to find the equation of all normals to the line, okay. The given line is 3x minus 2y plus 7, okay. Here first we write the given line. Given line 3x minus 2y plus 7 is equal to 0. Therefore its slope is, the slope of this line, it is a minus 3 by minus 2, that means 3 by 2, okay. Slope of this line, therefore the slope of the normal to this line, it is minus 2 by 3. The slope of this line, it is a 3 by 2, therefore the slope of the normal, it is minus 2 by 3. Therefore slope of normal to 3x minus 2y plus 7 is equal to 0 is minus 2 by 3, okay. It is a slope of the normal to this line. Here we use the condition for the slope of the perpendicular lines, okay. Now then, therefore the equation of normal is, here given that only the slope, therefore y is equal to mx, m it is minus 2 by 3, plus c, okay. It is a equation of the normal, y is equal to mx plus c, and here c is an arbitrary constant. Here c is arbitrary constant. Okay. And then differentiate this equation. Differentiate with respect to x. It is a dy by dx is equal to minus 2 by 3 plus 0. Okay. The derivative of y, it is a dy by dx. Derivative of minus 2 by 3x, it is minus 2 by 3, and derivative of x, it is 1. And c is a constant, therefore the derivative of c, it is a 0. And then it is our required differential equation. Okay. Here dy by dx is equal to minus 2 by 3. Okay. It is a required differential equation, or we can write 3 dy by dx is equal to minus 2, or we can write 3 dy by dx plus 2 is equal to 0 is a required differential equation. 3 dy by dx plus 2 equal to 0. Okay. Now we see the last example in the question number 4. Example number 5. form the differential equation of the the hyperbola. The hyperbola whose length of transverse and conjugate axis are half to that of the given hyperbola. X square upon 16 minus y square upon 36 is equal to k. It is a given hyperbola. Now, here first we want to find the equation of hyperbola whose length of transverse axis and the conjugate axis are the half of the given hyperbola's transverse and conjugate axis. Therefore, it is a given hyperbola. See carefully. Given hyperbola is x square upon 16 minus y square upon 36 is equal to k. That is, see carefully this, x square upon 16k minus y square upon 36k is equal to 1. It is our equation of the hyperbola in a standard form. Okay, compare with x square upon a square minus y square upon b square is equal to 1. Okay, therefore the transverse axis is a 2a. See carefully this, where a square it is a 16k, therefore a is equal to 4 under root k, and therefore it is a 2 into 4 under root k. It is a length of the transverse axis and conjugate axis. It is a 2v, and then it is a 2 into 6 into under root k. It is a length of transverse axis and the conjugate axis of the given parabola. But we want to find the equation of parabola whose length of transverse axis and length of the conjugate axis are half of this. Okay, now let the equation of required hyperbola is here x square upon, we take here capital A square minus y square upon capital B square is equal to 1. Here it is a capital 2A is a length of transverse axis and capital 2B is a length of conjugate axis of the required hyperbola. Okay, now here its transverse axis is a 2a and conjugate axis is 2b. Okay, transverse and conjugate axis of this required hyperbola. It is transverse axis, it is a 2a, and conjugate axis it is a 2b. But the given that here the length of transverse axis and conjugate axes are half of the given hyperbola. That means it is half of this hyperbola. And then given that 2a is equal to half of this, it is a transfer axis of the given parabola, it is a 2a, then it is a and that is 4 under root k. See carefully. And 2b is equal to b, therefore it is a 6 under root k. Okay, here 2a is equal to this and it's half, it is a, that means 4 under root k, and therefore we write capital A is equal to 2 under root k and capital B is equal to, here it is under root 3 under root k. Okay, here it is a and b, and therefore the equation of required hyperbola is, it is a required hyperbola, x square upon 4k, it is a square, minus y square upon 3k square whole square, that is a 9k, is equal to 1. Okay, here throughout multiplying by k, then we get x square upon 4 minus y square upon 9 is equal to k. So we multiply throughout by 36, it is the LCM of this, multiply by 36k. Therefore here when we multiply by 36k, k get cancelled, it is a 9x square. When we multiply by 36k, here it is a 4y square and it is equal to 36k, and here k is an arbitrary constant. Okay, here therefore differentiate with respect to x. Nine into 2x minus 4 into 2y dy by dx is equal to 0. Now this 2 to take common and get cancelled, and then last 9x minus 4y dy by dx is equal to 0 is required differential equation. Okay, see carefully this. Okay.